Hello AP Physics 1, it's Mr. Ng, and I have one of those sample problems out of our supplemental packets. This one is on momentum. So here is our problem. It says that a proton with a mass m and a lithium nucleus with a mass 7m undergo an elastic collision. Just a reminder, if it's elastic, that means energy is conserved. Remember that momentum is always conserved, but only when it's elastic is energy conserved. So find the velocity of the lithium nucleus. Well, I think the first thing we ought to do is we ought to just try to see what we can find as the ending velocity, right? We need to find the velocity of the lithium nucleus. So I'm just going to say that the initial momentum should equal to the final momentum. The initial momentum is m v of the proton plus m v of the, well, I'm going to do a big old M so that it's the big guy, and I'm going to do a big M there, that way it's this velocity, and this is of the lithium, should equal to the mass of the proton times the velocity of the proton final. I'm going to call this PF, I guess, plus big M, big V, FL. Okay, let's plug in. The M is an M. The first velocity is 1,000, so I got 1,000 M plus, this is 7M for this big M, so that's 7M times VL. The initial velocity is actually 0, so this whole thing goes away, is equal to the new mass, which is M. We don't know this velocity. I'm just going to call it VP now that this V is gone, plus 7M instead of big M, right? Same thing. And then I'm going to call this VL. Okay, that kind of sucks, but at least we could cancel out these M's. That feels good. So long, M's. So now I got 1,000 is equal to VP plus 7 V for the lithium. So to solve, that means the velocity of the proton is equal to 1,000 minus 7 VL, which is not enough, right? We have two variables. So for two variables, we need to do a system of equations, meaning we need a different equation. So thankfully, it's elastic. If it's elastic, I can use 1/2 mv squared. That's the kinetic energy. So the initial 1/2 mv squared, right? This is our initial system. So this is, I'm going to call it velocity initial. That's a little I there. Is going to equal to the final velocity of these two systems, right? I mean the final energy of those two systems. So this is going to be 1/2 mvp squared plus 1/2 big M VL squared, right? Let's try to simplify this as much as we can. We already know this V, right? This V is 1,000, so this is 1/2 M 1,000 squared is equal to 1/2 M. You know, instead of VP, I have an expression for VP. I could do a little bit of substitution here. So I'm going to write in 1,000. Oh, it's going to be ugly. 7VL squared plus 1/2. Big M is actually 7M. So 7MVL squared. Okay, that's a mess. But thankfully, I get to at least cancel out these M's. Get out of here, M's. I don't want you in my life. Okay, and then now we got to do a little bit of math here. It looks like I might need to end up doing quadratic. Let's see what happens. So 1/2 of 1,000 squared. 1,000 squared is 1,000,000. 1/2 of that is 500,000. Is equal to 1/2. Dang it! I gotta do FOIL here. So times 1,000,000. All right, and then this is negative 7 VL times 1,000 twice. So minus 14,000 VL plus 49 VL squared, right? Plus 1/2 times 7 VL squared, so this is 3.5 VL squared. Yuck! It's so ugly. It's the worst. All right, let's finish up. 500,000 is equal to, let's see, let's distribute this sucker. All right, simple arithmetic now. This is going to be, I'm just going to do a different ink now. This is going to be 500,000 minus 7,000 VL plus 24.5 VL squared plus 3.5 VL squared. Hey, something good happened. We could cancel out these 500,000s. So this becomes a little bit easier then. Then that means if I simplify it, that means 28 VL squared. I just combine these two suckers. Minus 7,000. Oh, awesome. VL is equal to 0. Hey, this is good. I don't need to do a quadratic. So that means VL times 28 VL minus 7,000 is equal to 0. That means maybe VL is equal to 0, or 28 VL minus 7,000 is equal to 0. That means 28 VL is equal to 7,000. Just have to freaking divide. That means VL is equal to 250 meters per second. Okay, that was quite a bit. How did I do this? Number one, I just made sure that the momentum in the beginning and in the end were equal to each other, and I got this expression, right? Then I was able to find a separate equation because I knew that the energies had to be conserved because it's an elastic equation, an elastic collision. So in an elastic collision, energy is conserved, so I was able to use 1/2 mv squared, and then I use this equation and that equation, this one, and I did a little substituting. I did a whole bunch of math and ended up with VL is equal to 250 meters per second. Thank you very much for watching.